This is Algebra 1, Lesson 5. Our objective is, what is the absolute value of a number, and how do I add signed numbers? You should be able to answer both of those questions by the end of this lesson. Before we get started with absolute values, though, I just want to ask you a quick question. How many miles do you live from the school? Yes, right now, answer it out loud. 1, 2, 3, go. Alright, so I can't actually hear you because it's a video recording. However, I can say that you might have said something like 3 miles. Or maybe you said 12 miles. But I can pretty sure, I can say with confidence that you probably did not say negative 12 miles or negative 4.3 miles. Why? Because we're talking about a distance. We're talking about a distance. So the absolute value of a number is also a distance. This is a definition from your book. It says the absolute value of a number n is the distance, notice I've highlighted it and underlined it in red, from n to 0. Always think about distance. Distance is always positive. Doesn't matter if you're traveling north or traveling south, you're still going a distance. Doesn't matter if you're going east or west, you're still going a distance. If you walked a mile walking forward, or if you walked a mile walking backwards, you'd still say you went a mile. So distance is always positive. We use this cool little symbol, 2 vertical lines around the number to indicate the absolute value. So whenever you see vertical lines like this, that means absolute value. So here's an example here. I drew a number line down here just to help us out. It says, what is the absolute value of 4? Well, 4 is over here. And remember, the distance, the absolute value of a number is the distance from that number, 4, to 0. So if I was at 4, I'd have to take 1, 2, 3, 4 steps. So this distance is 4. So the absolute value of 4 is equal to 4. Notice there that my answer is positive. The next one here is negative 4. Well, negative 4 is over here on the left. So it's wondering, again, how far is it from this number to 0? So if I started here, I'd take 1, 2, 3, 4 steps. So the distance from negative 4 to 0 is 4 steps. So the absolute value of negative 4 is also equal to 4. Notice my answers here are always positive because we're talking about a distance. So let's just try a few more of these. If you need to use a number line, feel free to do so, but I think you'll be able to catch on fairly quickly on how this works. The absolute value of negative 5, well, it would just be 5, because negative 5 is 5 steps away from 0. The absolute value of 3.9, well, 3.9 is 3.9 steps away from 0. So the absolute value of this would be 3.9. Over here, C says the absolute value of 2 minus 1/3. A couple different ways of solving this. Hopefully you have a couple tricks up your sleeve. Or maybe you can even just mentally do that. If I have 2 and I take away 1/3, that's going to be 1 2/3 left. So I'm actually looking at the absolute value of 1 2/3. Well, if I'm 1 2/3 steps away from 0, that means I'm going to be 1 2/3 steps away. Forgetting to box in my answers here, shame on me. Alright. Now D is a slight bit confusing, but I think you can still figure it out. Just don't go too quickly as you answer these. Actually think about what you're looking at. Notice this says the absolute value of 17 plus 24. So the absolute value of 17 plus 24, and then notice in front of that absolute value there is this negative symbol. So absolute value, again, is a kind of grouping symbol. So I'm going to do what's inside that absolute value first. So let's just continue on from here. This is going to be negative absolute value. What's 17 plus 24? 41, if I'm not mistaken. So what is the absolute value of 41? Well, the absolute value of 41 is saying how far away is 41 from 0? Well, if you're standing on the 41 on the number line, you have to take 41 steps to get back to 0. So then the absolute value of 41 would be 41. But notice I have not used this negative sign, so it's still going to stay right here. So my answer in this case is going to be negative 41, because I wanted the negative absolute value. So the absolute value is 41, and I want it to be negative, so it's negative 41. Alright, the next one is adding signed integers. And so we can kind of use this doing a number line, and we'll study more about this in lesson 5. But let's just use a number line here to help us out. I'm going to use this one right down here. So I'm starting out at 3. So right here is 3. And then I'm going to add to it a negative 3. Well, negative 3 moves in the... So 3 is starting right there. Negative 3 means move in the left direction. So I'm at 3, and I'm going to take 3 steps to the left. 1, 2, 3. And notice I'm ending up there at 0. So this is equal to 0. Looking at B, I'm going to use this one right here. Notice it says start at negative 2, so it's right here is where I'm starting. And then it says add 7. Since that 7 is positive, it means move in the right direction. So I'm going to take 7 steps to the right. 1, 2, 3, 4, 5, 6, 7. Notice I'm now standing right here on top of the 5. So that means this is going to equal to 5. This third one, C, I'm going to be using this one right down here. Notice it says start at the number 9. So it's going to be right here is where I'm starting. And then it says take a step in the... add to that negative 1. Since 1 is negative, it means move in the left direction. So I'm going to take 1 step going to the left, and notice now I'm ending up here at 8. So the answer to this one is 8. Alright, so what are some rules so we don't have to draw out number lines? You know, what if it said, what is 300 minus 161, or plus and negative 161, I guess is what I'm trying to say. That'd be a really long number line and a lot of counting. So what are some rules that maybe we could use and apply so that we could solve this in a simpler way? So there's 2 different ways when we're talking about adding. The first one here is adding with the same sign. So that would be like saying 5 plus 2. Notice that 5 and the 2 are both positive. Or if you were saying negative 5 plus negative 2, those are both negative. So that'd be an example with the same sign, because notice both numbers are either both positive, they're both negative. So the book kind of illustrates this. It has a little box there that talks about it. This is kind of my summary of it. Just add the numbers. Kind of forget about what sign they are for a second and just add the 2 numbers. And then you keep the same sign. So in this first case, I would make sure that my answer is positive. In the second case, I'd make sure my answer is negative. Why this is because you're going to keep moving in the same direction. Negative 5, you're going to start on the left of the number line. Sorry. If I start with 5, I'd start on the right of the number line, and then I'd add 2, moving further to the right. If I started with negative 5, I'd start on the left of the number line, and then I'd add a negative 2, which means I'd be moving further to the left. So they're going to be adding those numbers together, or technically we'd be saying adding their absolute values together. So just for simplicity's sake, you add the numbers, forget about their signs, and then keep the same sign. So 3 plus 2, notice they are both positive, is going to be 5. Negative 3 plus a negative 2, you would add those together, negative 3. So 3 and 2 is 5. Notice they're both negative, so then I keep that negative 5. Okay. The next one we do is adding integers with different signs. So that'd be like kind of saying 5 plus a negative 2, or maybe negative 5 plus 2. Notice the first one in both these cases, well, here the first one here is positive, the second one's negative. Here the first one's negative, the second one is positive. So they have different signs. One's positive, one's negative. So since they have different signs, think about this top one here. This positive 5 means I would start on the right-hand side of 0, and I would add to it a negative 2, which means I need to go left 2, moving back towards 0. So notice it would be a number smaller than 5. This one I'm starting at negative 5 to the left of 0, and then I would be moving right 2. So we're kind of going two different directions there. So since they're different signs, what we're going to do is we're going to subtract the numbers. And for easiness sake, simplicity's sake, I would say the bigger minus the smaller. Now, whenever I say bigger minus smaller, I'm actually talking about the absolute value of those numbers, because notice here, this negative 5 and 2 is actually bigger than negative 5 because it's further right on the number line. However, for this case, just in my mind, I would be saying 5 minus 2, because the absolute value of negative 5 is bigger than the absolute value of 2. So that's what I kind of said, bigger versus smaller in quotations there to kind of help you out with that. And then after you do that, you need to use the sign of the quote bigger number. Again, we're talking about the bigger in terms of absolute value. The absolute value. So here we go. Let's look at this couple examples here. 3 plus a negative 2. Well, I would just say different signs, so I'm going to subtract. 3 minus 2 is 1. And then since 3 has a bigger absolute value, I'd keep the sign of it. Notice this number is positive because there's nothing written there. So that means this one would be a positive 1. We'll give us a positive 1. Notice here on this next one, we have a negative 3 plus 2. So I'm just going to subtract those numbers. 3 minus 2 is going to give me 1. But this one here is negative. This is a bigger number, if you want to say. 3 is bigger than 2. So then I'm going to keep the sign here of negative 1. Now, one last concept we have here is the idea of being closed. And this is kind of the book's definition here. It says closed. A set of numbers is said to be closed under an operation if the outcome of the operations with any two numbers in the set is also